I am really pleased now to introduce our second speaker, which I'm really glad to thank for being here. The second speaker is Professor Steven Loisel, which is a senior researcher lead at Earthwatch Europe and an associate professor at the University of Siena in Tuscany, in Italy. Through the Freshwater Watch Global Citizen Science Program, he has worked with the communities and in partnership with business, regulatory and research stakeholders on key local and global environmental challenges. By increasing the exchange of information and knowledge between partners in more than 40 countries across Europe, Africa, Asia, and the Americas. Loisel has coordinated international research in African Great Lakes, in Paraná wetlands, and in Mediterranean lakes, and shallow lakes in the Yangtze Valley. Professor Loisel's research has focused on the dynamics of ecosystems in the context of global megatrends, resulting in 120 publications, chapters, and books. Today, Professor Loisel will speak about the Citizen Observatory for monitoring the local aquatic ecosystems of the Pesa River in Tuscany, Italy. So, dear Professor, thank you for being with us. I'm very glad to leave you the floor.
Thank you very much, Sarah, and thank you, Professor Janai, for a very interesting and exhaustive presentation on everything in Tokyo. I'm going to share my screen now, hopefully. Okay. Okay, that's over here. Okay. Okay, Sarah, can you see it? I'm going to
we can see
make it into a slideshow form. Okay, so I'm going to present today a little bit about citizen science, so participatory monitoring of aquatic environments, with the idea of showing what's available out there and concentrating on a project that we helped develop called Freshwater Watch. So first of all, I'd like to introduce Earthwatch Europe. So Earthwatch Europe is a NGO that's in several places in Europe, but housed originally in Oxford. The idea is connecting people with the natural world. So there's a whole bunch of projects, not just on water, also on trees, on biodiversity. The idea is connecting people and empowering people. So we provide instruments and technologies and databases and training that allows communities to monitor the health of their local environment. The idea here is to inform the communities, but also work with, in almost all these projects, we're working with agencies, local scientists, river trusts that are trying to find a solution to a particular problem. Today's talk, I'm going to talk a little bit about why water. Why is there a growing need to monitor this? Why is this becoming a priority for places across the globe? Why citizen science? So again, why bringing communities, bringing people into the picture is important. I'll talk a little bit about Freshwater Watch, how it works, to give you guys an idea of how a citizen science program could be set up or is set up, and also what are the key factors. I'm going to give you a whistle-stop tour of some of the projects, including that of the Pesa, which is a river very close to where I live, that's very close to my heart. And then we're going to wrap up with kind of seeing how citizen sciences can be a key to solving some problems. I don't know, saving the world may be a little extreme, but let's look at that together. So water is a precious resource, as you all know. It's traditionally, as we saw in Edo period, Tokyo, and before, it's key to societies, key to our history. It's also key to a whole series of services that most people don't even consider, don't even think about. So these kind of ecosystem services that have become important for agencies, for policy development, for communities. And so bringing out the importance of water and maintaining and empowering people to contribute to making their aquatic environment healthy is becoming more and more important. I'm sure you've all seen the study from Costanza, but the fact that these ecosystems, lakes and rivers and wetlands have a massive value to them should be a disincentive to policymakers and planners to stop paving over them or allowing encroachment. And in a lot of places we're working, it's still happening. So in places, especially in some of the mega cities in India and China, it's still difficult for policymakers to conserve a wetland, to conserve enough space for a river to follow its natural path. But the studies are there to show how valuable they really are. There's increased pressure, and in a lot of places in the world, this is coming to a head from a political point of view. But flooding is an ongoing and increasingly important aspect of a policymakers, of a citizen's daily considerations, where he or she chooses to buy a house or and whatnot. Nutrient enrichment, eutrophication is a massive problem throughout the whole world. Sewage pollution, pesticide pollution, agricultural pollution, plastic pollution has gotten the headlines over the last 3 or 4 years. And this is inevitably caused by poor management, poor policy, and just a growing number of people who want to consume more and more. And this has led to a biodiversity loss, a habitat loss, and just a general loss of the quality of the aquatic ecosystems on which we've always depended as societies. Of course, this isn't helped by the fact that the population is increasing, and it's going to continue to increase. And not only the population is increasing, but it's on an average consuming more and more. So it's not a problem that's going to go away anytime soon. And it's a global problem. It's a global problem that's being faced by communities with more or less capacity to deal with it. So there's lots of new pollutants. Every year, every day, there's new pollutants getting into our aquatic ecosystems that are having impacts on the way these ecosystems function. So the services they provide, the quality of the water that's eventually used by nature or by ourselves. There's more than 1 million people who die annually from diseases associated to poor drinking water and inadequate sanitation. So the whole wash area is an important area where there have been significant gains over the last decades, but there's a lot more to do. The ongoing human illness and deaths associated to antimicrobial antibiotic resistance. This is putting a lot of pressure on wastewater treatment, and trying to find a solution to this problem it's not going away. And of course, the agricultural sector, on which we all depend, which is not a bad guy in any way, but they are the largest consumer of fresh water, and they're also one of the major drivers of eutrophication. So there is definitely some large improvements to be made, and we're working with farmers across the globe to try to give them the information and the capacity to help them monitor their own ecosystems. And then there's lots of developments in the agricultural sector to try to get less impactful and more sustainable production. This is not new, of course. The Sustainable Development Goals incorporate lots of objectives, lots of indicators, and one of the key areas is Sustainable Development Goal 6 that is setting out the objective of reducing pollution, eliminating dumping, and reducing the amount of untreated wastewater. And this can be done, and it should be done, and it is being done, but it needs to be monitored, and it could be monitored by agencies, but in most of the world, agencies are getting less funding than they used to, and that's getting to be a problem. It could be funded by communities, and that's where we step in with citizen science, and I'll show you a couple examples of that. So, citizen science. There's always been some sort of citizen science, because there's always been people who have been linked to their aquatic ecosystems, and Professor Janai showed lots of people very much tied to their aquatic ecosystems. And some of those people were in charge of or took on the responsibility of monitoring, of seeing how things change seasonally, how things changed over years, and trying to find a way to understand how those changes could be pushed towards positive results and stopped when they were going in negative direction. So citizen science is not new, but it's something that's becoming, rather than a niche, it's becoming something that's more and more popular. And the fact that it's becoming more and more popular is rested on lots of things. First of all, the fact that we all have a computer in our pocket with our smartphone gives us a lot more capacity to understand things, but also to record things and communicate things and get information back. There's also the fact that crowdsourcing and participating in large masses together, even though we may be geographically separate, is now a common thing that's part of our life through social media or through the many things that groups of people get together virtually to do. For example, today's lesson. We're getting used to the Internet of Things, the fact that we can all be connected and share information and take advantage of that. Cloud computing is allowing very fast calculations and very fast exchange of information. And then, of course, there's a growing environmental awareness. A larger part of the population does go on to go to university, does go on to be reasonably well educated, and sees the possibility of joining in to help improve the environment around them. And so citizen science is born, and you can see from this graph, from the number of publications that there were 2 decades ago, which is a few, to the number of publications that there are now, means there's lots of people, lots of scientists, lots of agencies that are getting interested in this. And it's providing all kinds of opportunities to engage the public in water, in their local environment, but in understanding, participating in the policy of, and monitoring the environment around them. So this is allowing all kinds of information to be gained that couldn't be gained before. It's increasing the power of the people, or let's say the participation of the people, in how their environment is managed. It's opening up new opportunities for education, new opportunities to bring people into a more sustainable way of thinking, a more sustainable way of behaving. And it's allowing scientists to do things with large quantities of data that they could not do before. So the Freshwater Watch was born approximately 10 years ago. The main objective was to come up with a system, a platform, an approach that would help communities and local groups to better manage and protect their fresh water. This is done at a global scale, so the same methods that are used in one place can be used in the other, and therefore can be compared. So we can compare experiences, we can compare solutions, and we can compare conditions. So all this is through communities of citizen scientists who are usually working with a local university or a local agency or a local river trust for a common objective, looking towards solving a problem or improving their local freshwater ecosystem. It's a global program. As I said, there's more than 80 projects that have gone on around the world, essentially everywhere where there's people. 30,000 measurements, they're all open. So you can, if you just go on Freshwater Watch, you can see all the data, and you can query the data or download the data or whatever you want. There's more than 10,000 people that have participated or are now participating. It's generally a program that starts from the bottom. So it's not a top-down program that tries to recruit people from Earthwatch Europe or from some body. It's communities and groups or catchment, people around a catchment that want to do something to improve the catchment, to understand what the conditions that are going on. And it's something that's bottom up driven. How it works? Well, the first objective, or the first reason why someone would do citizen science is they have they have hypotheses, so they have a problem that they want to look into and try to resolve. That person usually generates a certain amount of interest, and then that person becomes the community. And after a certain number of participants are engaged, they sit down and they try to figure out, using a common methodology in most of from experiences that we've had in all these projects. They try to co-design a monitoring plan together with local stakeholders. So the stakeholders could be the local environment agency, or it could be the water company, or it could be both, or it could be farmers, it could be lots of people getting together and saying, okay, what do we want to do? We want to work together to try to find a solution, or understand what the situation is, or understand when the critical moment are, where the pollution hotspots are, whatever that happens to be. They focus and they sit down and they come up with a monitoring plan together. And that's where Earthwatch or the local university come together and support that from a scientific point of view. Then the participants, the future citizen scientists, go through a training program. It's a standardized training program that's usually done following a certain protocol. It's focused a lot on safety. It's focused a lot on the quality of the data. It's focused a lot on engaging and informing the participants so that they can go on to understand why they're doing it, to be able to explain to their neighbor why they're doing it, and to understand the results. They go out and they collect data using a standard method that's been tested and quality controlled. And then they take those measurements at a certain geographic distribution, but also at a certain temporal distribution. So that may be once a month, it might be once every 6 months, but it's focused on what they're trying to measure. It could be event driven after a rain event, or it could be just regular, trying to supplement or fill in information that the local environmental agency can't measure or doesn't measure. The data are analyzed. So the data are analyzed for responding to the hypothesis, or looking at the problem before and after a potential source, wastewater treatment plant, before or after a restoration event. The data are analyzed together with the tools that are provided online, or provided by the local university, or by Earthwatch, or by whomever, always with an eye at making sure the quality control of the data is such that the data can actually give reasonable answers, can respond to the question that's being raised. Then there's an aspect of feedback. So there's an automatic feedback through the app. So the Freshwater Watch has an app that goes on your smartphone. You can download free. It's in about 10 or 11 different languages. And once you've uploaded that information, once you've uploaded the data, these tens or hundreds of people who have uploaded the data, they automatically get feedback that helps them understand what that data means. So what are the conditions of the water body, the river, the lake? And what does that mean? So it's an ongoing, continuous learning journey, so that the first time the citizen scientist makes those measurements, he or she will understand a part, but after they've made 3 or 4 or 5 or 6 or 10 or 20, they become very well informed of what that means. How has that changed from the last time? Are we seeing something that's particularly important to report or important to act upon? And that creates discussion. And the idea is that the citizen scientists, who are now empowered with information, empowered with some knowledge, work together with the local agency, work together with the local scientists or local river trusts, and try to find a solution, try to create a series of actions that can then improve or resolve the problem that they're seeing. And improving and resolving the problem that they're seeing and trying to understand the results is something that is done together, again, in a co-designed fashion, so that the idea isn't to find the bad guy. The idea is to find a solution that can help resolve the problem, that can bring these freshwater ecosystems back to a more functional state, to a more pristine state, or to maintain them in a pristine state if they're already there and they're threatened by some action or some land use. So as I said, there's methods are consistent. So wherever you're doing wherever the people are making the methods, they're comparable. They've all been quality controlled. There's a continuous series of quality control in the database, but also in the instruments. The instruments are very low cost instruments. The idea is that they can be done by everybody after a certain training. There's an online database and all the data is open. So after this, or while I'm speaking, if you want, you can go onto the Freshwater Watch site, go to the part where it says, I think it says our data, and you can go and see the measurements, and they're uploaded in nearly real time from smartphones. There's a quality control. It's done in a series of layers, automatic feedback, standard training, and a network of project leaders. The nice thing here is that we can get experience that's gained in New York and pass it to Buenos Aires and pass it to Freetown and then pass it back to Pisa if we want. So the idea is that the information flows from one project to the other, allowing project leaders to, again, learn as we go and as experiences occur. So now I'm going to give you, as I said, a quick tour of some projects, and hopefully that there'll be something there that link to what you're working on within this program, what you're working on in your local area. So we'll start from the north and then head south. So one interesting project is in Oxfordshire, so not far from where Earthwatch Europe is its main headquarters. And John Pratt, who started noticing the quality of his local river. As you can see, it's a very small river, was starting to go down. It was going down in particular moments of the year, in particular moments that weren't irregular. So there wasn't a seasonal variation. And through the project that John Pratt helped create using Freshwater Watch and taking measurements, they started to notice, so they started to verify that the problem was related to a wastewater treatment plant, a small wastewater treatment plant that was run by the local water company. Expanding that out, this became a large-scale, major project that has the Environment Agency in it, has lots of citizen scientists in it, has the water company in it, has a local association, Wild Oxfordshire, in it, that have set up management across the whole catchment, so not on just this little stream, but in the main river that this stream feeds into, to monitor, in this case, phosphorus pollution, and what are the different sources. So this is turned into, from a small little study on a stream that John used to fish out of, has become a major catchment study on a relatively important river in the south of England. And this study is ongoing, and at this point there's automatic sensors being put in, there's the number of participants increasing, and what they're trying to do now is find solutions. So they're trying to see what alternative use of what alternative farming approaches could be used. What can they do to reduce the sediment and the phosphorus that gets into the water after particularly strong rain events. The water company is putting in strippers to reduce the amount of phosphorus that gets into the river from their plants. So it's a solution-based project, but initiated and supported, because the number of measurements here from the environmental agency, the Environment Agency, is very limited. So there's a much larger coverage done by citizen scientists. Another interesting project very close to Sarah, geographically, probably not, is in the Piave River, which is a major river in Italy. And the Basso Piave, again, done by citizen scientists. This was the objective of this was to try to understand ecosystem services and project out potential scenarios where ecosystem services could be improved. So this part of the river starts after the Alps. It's a beautiful river that makes it down into the part that's called the Basso Piave, so the lower Piave. And in the lower Piave, it essentially becomes a canal. It's not really a canal, but it's not a very active from the point of view of hydrodynamics, not a very active river. And all the measurements that are being done by the local agency, ARPAV, which is like the environment agency of the region, have been done all in the upper part of the river. So really, there's not a lot of information on what's happening in the lower part. In the lower part, I mean, after Ponte di Piave down to where it goes into the sea. And so citizen scientists are making measurements, and their measurements, both of the water, the river, as well as the vegetation around the river, have become fundamental, or were fundamental for this analysis of ecosystem services. So again, particular challenge, how are we going to understand what's happening in this river? There's not enough information, and citizen science, in this case, came to the rescue. Another project is the one that my colleague Maurizio Bacci started up in the Fiume Pesa, so a river behind here in Tuscany, looking at what was happening with the quality of the river. The river, this is a small river that in the summer essentially practically dries up, but it's an important river. It has lots of communities around it. And this study that went on for a year was funded through a collaboration between the water company, Publiacqua, the Consortia Bonifica, so the River Trust, and the University of Siena, where I work, and the University of Florence, where a couple of these white-headed gentlemen work, and one of the local municipalities, San Casciano. And this project was, again, very successful, trying to understand what's happening to the quality of the river in this, the quality of the water in this river. Why are there certain moments when there's some severely poor water? And they found some super interesting results. So one of the main drivers of poor water quality are these rural houses, like the one that I'm living in, that go through the water from the house, go through a series of water treatments, let's say black water treatments, at the house, but then they're slowly released into the environment. And this water source is very high in nutrient and organic pollution, which causes major impact on the receiving waters of the river. It's an interesting impact because it's an impact that causes pollution, but it's also, in the summer, these are one of the few sources of water that make it to the river. So it's fun, these rural housing waters are allowing for the river to continue during the hottest months of the summer, so providing a minimum environmental flow. So all the results of this project are now informing water management, informing how rural housing, how the houses and communities can get together to try to reduce this impact while maintaining a minimum flow that goes into the river that keeps the river alive during the summer. So again, these are normal citizens, apart from a couple of the gray-headed people who work at universities, normal citizens spending time to understand their environment and try to find some solutions. Going across the globe to China, citizen science in China is growing. This was a project that was done a few years ago together with the South China Agricultural University. And the idea here is in this part of China, so we're looking at the Guangdong province in China, where Canton is, or Guangzhou, near where Hong Kong is. And there's a major river, the Pearl River, which is, I think, the third major river in China, that has all kinds of pollution problems. And a lot of it is related to how agriculture is performed within this very large, gigantic water basin. And the South China Agricultural University was coming up with different methods to reduce the impact of agricultural activities, reducing the impact of agricultural activities, and then monitoring it. Across such a large area, it's difficult for a university to monitor it. So with citizen scientists who are monitoring it, and they validated some approaches that were actually that could improve how agriculture was performed and reduce the impact of agriculture on these very important water bodies that provide water to millions of people. And so this was a project that was concluded a few years ago. Another project that's ongoing is in Brazil, where there's, I don't know if there's any Brazilians in the meeting, but Brazil has an ongoing problem that lots of the reservoirs become full of cyanobacteria, become full of algae that make the reservoirs no longer fit to use for drinking water. So this professor, you can see in the upper right, David Cunha, this is the second project. He's done some brilliant projects using Freshwater Watch in different places in Brazil, but this one is close to where the university is, enlisting people who live around the reservoir to take measurements using this standard method, and then use these measurements to understand when cyanobacteria blooms are occurring or could occur, and then try to find out where the sources of these pollution are, and work on ways to move that from problem to solution. Another project, and this is one of the projects that we're using to try to support the SDGs, because one of the challenges with SDG, the UN SDG Sustainable Development Goals, is getting countries to report the status, or to report to the indicators that are required to see what the conditions are across the globe and how they're changing. In some cases, the challenge for some countries is there isn't just enough information to allow them to report. So bringing citizen science into the picture is a big help. So this is the water agency of Zambia, together with WWF, and together with a very small educational foundation, are taking measurements all along the Kafue River, which is a massive river, and feeding that into the national agency, that are then now planning on using this to report to the next United Nations reporting period for SDG 6.3.2. And we're also doing a similar project in Sierra Leone, again, working with the national agency. And these are very powerful projects because they bring lots of people from many communities together to monitor what's happening in their local water body, and then to try to find solutions, because a lot of the problems in these local water bodies are locally driven. And by informing the people, allowing people to make the relationship between the quality of the river, which they depend on, and their actions within the farm, within the local community, it's pretty key. Another example of this is Lake Tanganyika. So Lake Tanganyika is the longest lake in the world and the second deepest lake in the world. It's 700 kilometers long, so it's massive. But we have communities along the northeastern part in Tanzania who are monitoring, using the Freshwater Watch program, who are monitoring the coastal conditions. And these are the coastal waters that they use for washing, that they use for fishing, that they use for lots of things, but that the conditions go up and down depending on their actions, but depending on the climate or the local meteorological conditions. And so to understand how these actions influence the lake, how these actions influence the coastal water quality, these communities are now monitoring the coastal water quality using Freshwater Watch. And it's nice here because you say, well, this lake it's as big as 2 or 3 Italian regions. How could communities be changing the water quality? But if you take the lake as a whole, the lake is still very, very clean, very oligotrophic. Along the coast, though, you have some severe problems. And one of the things we're monitoring here is fecal coliforms and where these are coming from and how this can be reduced, because these waters people are in contact with these waters all the time. So again, informing communities, empowering these communities to take measurements, and take measurements that can be used for making decisions, for making local decisions, and making also policy decisions. The last example I wanted to show you was this pan-European blitz. So every year or so, there's different cities sign on to participate at the same time in a massive monitoring experience, where hundreds of people go out in each one of these cities to take measurements all in the same weekend. And this allows, first of all, information that no agency or no scientist or no university could possibly gather, because we're talking hundreds of nearly 1,000 measurements in this one, all done over the same weekend. So all done in the same, more or less the same meteorological conditions. So you have a map of a catchment, and this is the Thames catchment, which is very large. That's very unique. And from that, you can understand where pollution hotspots are, where more than the pollution, where are the places that in tributaries, ponds, rivers, where are the places where there's actually good quality water, where something needs to be conserved. On the other hand, it's also bringing thousands of people into the picture of understanding their local environment. And so this is and it's fun because you actually get to compare, you get to have a competition between major cities, so London, Paris, Dublin. You get competition of who can get the most people involved, but also what is the quality of the water. So this is an interesting, and it's something we've been doing over the last 3 or 4 years that's expanding. So it was originally just in the Thames, and now it's expanding across Europe, but there's no reason it can't be done anywhere. The part that's interesting is doing it all in the same weekend. You can start to make some comparisons between cities and between also restoration efforts and efforts to improve the water. So will citizen scientists save the world? They'll help, I think. Citizen science, there's enough information now to say that citizen science produces new knowledge. The number of publications that have been based on new knowledge, new developments that have been published in scientific journals based on citizen science is growing. Earthwatch probably has 40 or 50 over the last 10 years. It improves policy grounding. So policies are made from a top-down level, but if they're made with bottom-up support or bottom-up pressure is influencing those policies, they're usually more sustainable in the long run. And getting people to be part of the governance circle is a key part. It increases public awareness, without a doubt. Getting thousands of people or communities all along a river stretch to be participant is fundamental to making change happen. And citizen science is one way to increase participation, increase public awareness. It also brings in an element of democracy. So the part about giving people information and giving people the knowledge makes democracy work a lot better. And from a scientific point of view, it's allowing us to test solutions. So restoration efforts, constructed wetlands, some of the things that even Professor Janai showed in those pictures where there's a greening along the riverway, to test the benefits of that for the overall quality of the river is very much supported by having people making measurements before and after in different seasons, and then justifying the expense of creating a river corridor simply through an improvement of the water quality, improvement of the habitat, improvement of the biodiversity, and just the improvement of the ecosystem services that are provided by that river. So I've spoken too much, but all of this, of course, couldn't be done without the thousands of Freshwater Watch volunteers. As I said, Freshwater Watch is a global program that's in a whole bunch of languages, so it's something that's opened to expand, to be used. It's a platform that saves. The idea behind this is it's something that will allow someone to create a citizen science project that's robust, that's functioning without having to start from square one. So thank you for your attention, and I hope you have some interesting comments.